always remember there are videos on a YouTube page or YouTube channel that I have. Several videos on that channel have to do with the DE-3000 software. So if you need anything for reference throughout the days as weeks go by, et cetera, those all are available. So typical DE-3000 system, this is an actual photograph of an actual system that's sitting directly behind me. For today's demonstration, I will be plugged into this system. A little bit of a detailed view of the system. On the back, you can see port 1. Port 1 has a DB9 pin connection or a USB printer cable. For today's instruction, I will be plugged into the USB printer cable type connection. If you don't have the DE-3000's terminal program installed on your computer, always remember you can go to our website under the download section and scroll down to the bottom of the download page to terminal programs and select a product. The DE-3000 is listed in there somewhere. Oh, there it is. And the current version, as of a few days ago when I put this slide together, is version 2.1. We will always have the newest version software there. I strongly recommend that you always are running the newest released version of the software. And with that, once you have it installed, let's just take a quick look at the software. So I'm physically opening up where I keep the icon for it. You can see Altronic DE-3000 version 2.1. And it tells you it's 2.1 as it's booting up. And this is something that was introduced in mid-2014 when we released the DE-3000 Enhanced system. Just a little message. It says version 2X contains added features to the DE-3000. Please verify both the display and terminal boards contain the firmware dated for 2014 or newer in order to use these functions and to the program the DE-3000. If either of these displays or terminal boards contain firmware dated before 2014, so it'd be 2013 and older, please use 1X. So this is one of my favorite screens. I get a lot of phone calls where people can't communicate properly with the DE-3000 for various reasons, but this is the ideal check. When you open up the software, it starts immediately looking for the DE-3000. And in this case, if we view the message displayed in the lower left-hand corner, it says that the DE-3000 was found on COM port 3. It also selected COM port 3 for us automatically. And the only thing that you really have to do on this page is this. You have to have a username of some sort entered in at the top. It doesn't matter what you have there. In my case, it selects my company username automatically. In some cases, I've seen people's computers where it does the same. In other cases, I've seen where people's computers leave this area blank. It's, again, with your individual company, how the IT person set up that computer, et cetera, et cetera. Doesn't matter what you put here as long as you put something. The display firmware dates and the terminal board firmware dates, unless you're doing some type of backwards compatibility issue, I've never reached a situation where I had to do anything here, so I recommend not touching them. At the same time, if you ever open up the software where you're not connected to the DE-3000, maybe you're down the road or in an office and you're planning on going out the field later, that's fine too, but version 2X will be selected automatically. So watch out for version 2X and watch out for version 1X. Know the systems that you're working on. Again, version 2X will be the default if it's not connected to the DE-3000. If it's connected to the DE-3000, such as we are right now, when it finds the DE-3000 and selects the COM port for you automatically, it will automatically select version 1X or 2X. I happen to be connected to a 2X system with firmware 2014 or newer, and so I am good to go. And at this point, I will simply select OK. Now, with that, I want to pause for just a second and show you something that's on the background. So I have a folder where I've pre-stored some files for this class, and I just want you to take a quick look at them. I'm connected to a lab piece with a one-board system, and so the programs that I have for this are named lab unit. I have a PG7 file and a T1 TR7 file. The PG7 file is the file that's actually in the display. The T1 TR7 file is actually the file that's located on the primary terminal board. Now, just for fun, I included an older version PG6 file, or PG6 setup. Now, PG6 represents the fact that it is the older legacy DE-3000. So between 2007 and 2013 we use a 6 as an identifier, or AKA version 1X. Now this system happened to have an expansion board, so we have a third file called T2 TR6. So it's pretty easy. The 7 identifies if it's a version 2X. The 6 identifies that it's a version 1X. The T1 identifies the primary or number 1 terminal board. A T2, a secondary terminal board, and that terminal board could be a 15 channel or a 30 channel. We don't know until we open up the program. And then the PG obviously indicates that that's the file for the display system. So with that, I'll return back to the software. And we can see several functions across the top. Last week, we used this software a little bit, and we talked about the calibration feature. So we have exit, calibrate, host, monitor, print, send to DE-3000. Now that button has changed. Hadn't changed its function, but it's changed description in the last few years. And we have configure. Now, sometimes I'll be supporting a person on the phone and they need a little help, and I ask them, well, what version software are you running? And they don't know. Real quick, while we're on this screen, we can find out. We can simply select help and about the DE-3000, and it'll tell us that we're running the DE-3000 controller program, and it says terminal program version. You can kind of skip over the date and just go straight to the end, version 2.1. Some people don't know that is there. Okay, so what I want to do is just show you a few things about the DE-3000 that we hadn't covered in any of these training sessions yet, and I'm going to select monitor as the first thing to show. When you open up the monitor section, the first thing you do, and this is just forced to habit. I'm not saying you have to do this, but this is what works best for me. And when I find something that works good, I tend to not deviate from that and do it constantly. And I'll also teach that. So the first thing that I do is I select hang up, and then I select connect. And this gets a little confusing because the first thing everybody's eyes zoom in on is this modem connection section. And you start trying to fill it out and you're not sure what to do. Skip it. I'm direct connected right down here. Direct connection, COM port 3. So I'm simply going to select connect. Now what this does is it gives me some information about the program that's in the system. It gives me the time and the date of where I'm at. It gives me the status, manual stop, and it shows me my home screen labels and their readings. And it shows me 12 other key readings. And this has been true for since the creation of the DE-3000 in 2007. This is really nice if you're trying to get a snapshot to prove to somebody that it was running maybe the way you said it was when you left location. I used to use this feature a lot when I was a commissioning tech for one of the major lease fleet companies. If you need to, if you're monitoring something out on site, you can also, from time to time, select Get Current Data Snapshot, and it'll just update and give you a new current snapshot. So this is not a live action. This is just frozen in time from what we would call a snapshot. And if you're done with monitoring the DE-3000 and you simply want to exit, just select the exit button and you're back to the main home software screen. So with that, I want to just open up the software and we'll kind of go through a few scenarios on the control strategies, and then we'll spend some time with the channel section. So I'm going to click Configure, and this is my preferred method that I will say no matter what you're doing, whether you're going to put a program into the DE-3000, play with a program you already have installed on your computer, anything, configure. And here's why I like it. As soon as you click Configure, a new window opens up, and it's very, very direct. It gives you the choices. I can create a new one. I can retrieve from a DE-3000, or I can retrieve from a file that I've stored a previous program at, or I can cancel and simply back out and close this window. So if I retrieve from the DE-3000, it takes a few minutes, obviously, to pull the program out. But one thing that I'll be clear about is you're not erasing the program that's in the DE-3000. You're simply pulling a copy of it out. The only time you have to be concerned about erasing what's in the DE-3000 is when you go to actually program the system. That is why, in a lot of cases, I do not recommend people to click on this send to DE-3000, because that means exactly what it sounds like. You're going to send a program to that, and it gives you an opportunity to select the program that you're going to send, but doesn't give you necessarily an opportunity to review that program. And I find people accidentally put the wrong program in. So today what we're going to do to save time is we're going to select Retrieve from File. Now notice I'm in with this browser window that the software just opened up. I'm actually in the same file as I have displayed in the background, and I'll switch over to it for a minute. So I have two main programs in here. I have a Unit Lab program, and I have an uploaded program that somebody shared with me a few days ago. Again, there's 3 files for this one because it does have an expansion board. There's only 2 files with this one because it only has one primary board. But if I switch over back to the software browser, the browser is only showing me the PG files. It's not showing me the terminal board files, and that's okay. We do that on purpose to keep a person that's working in the field and working with the software from getting too confused, because if you have multiple units listed and stored in the file that you're going to, and you're seeing up to 3 files for each unit, it could get quite confusing. So we're just keying in on the PG files. So I'm going to select this lab unit, PG7 file, and simply say Open. And it brings me straight to the Program Global Variables page. And this is the key page. And this is the heart of the system as far as the automation startup process if we're using this feature. But we're going to cover each scenario right here. So bear with me, and please, again, like David Bell said, if you have any questions, please push and hold your space bar and feel free to ask, and I'll do my best. Okay, so we can see a few things going on here. First, it's telling me that my display board firmware date is 8/11/15, and I'm fine with that, and it happens to match that of my firmware. I've viewed what my firmware was through my keypad. It also tells me that the number of terminal boards in my system is 1. And it tells me my node address for the system is 1. So this is for telemetry purposes if I have a telemetry system or a SCADA system connected to port 3 down on the power supply board. It also gives me some nice global timers. In this case, the Class C timer is defaulted to 10 minutes, and this affects globally all C timers. It's telling me my test time when I put it into test mode is 120 seconds. And it's telling me that my cooldown timer, if I use the cooldown feature, is going to last for 300 seconds. Giving me today's date and today's timestamp. It's also telling me a little bit of information, and I apologize about this name here. Let me just take and change this to, we'll change that to lab test right now. This affects nothing other than any documentation and reports that stem from this program. It gives me a few choices down here at the bottom of the page. It tells me the data logging report header is now going to be lab test. It tells me that the data logging interval is going to be every 5 minutes. Now, when I hold my mouse over that, it does tell me that I can select anywhere between 5 and 999 minutes. Generally, most people like the lowest number, so it is defaulted at 5, and that's where I always leave them at. I've never known anybody to want a larger number. Continue data logging after a shutdown. No is the default. So we have basically 99 points of data logging intervals that we can store, and we can view that at any time later in life throughout the system. But once those 99 points are filled, as it brings in a new point, it's going to erase the oldest point. So if we're trying to catch something at a shutdown event, once we're shut down, we don't really want to continue to sit there and record data, because we may get to a point, if it's a time, quite a bit of time before somebody gets to the location or gets to the unit to check it out, that we could lose what was going on at the time of the shutdown event. So no is the preferred method here. Erase all data logs on power up. Well, this is another bad thing, because if somebody turns the unit off waiting on a senior level tech to get to site, and then that senior level tech gets to site, if this is selected as yes, any data log that's in the system is going to be erased. So again, these are the two defaults. Now, before I get into the startup sequencing, I'm going to jump up to Terminal Board 1 tab. So we can see that we have one terminal board selected. If we add a second one, we'll see that second terminal board pop up. I'm going to keep it as 1 and just click on this Terminal Board number 1 tab. This is a main terminal board. It's defaulted as a 30 channel with 8 digital outputs. You cannot select an expansion board for the main terminal board. It gives us a few options. On-off control for outputs 1 and 2. Again, by default, that's the most common. Or solenoid pulse control for outputs 1 and 2. And here's where I can change that. So if I was setting up something for a screw compressor application, or any application where I needed to pulse something on and off, I might use this selection right here. And then it's asking, if I do use solenoid pulse control, what do I want to do at unload, pulse, stop, fault? I can tell it basically how fast to start unloading the system. Pulses per revolution. This is where you would enter in information for, in generally most cases, how many flywheel teeth you have. If we're using a magnetic pickup, to select to monitor engine RPM, and when we're keying that in off of the magnetic pickup, this is where we would tell it how many teeth are on our flywheel, or how many pulses per revolution from that magnetic pickup. Know that some people use electric motors, and I've seen people go as low as 1 pulse per revolution, although we recommend really not going as low as any lower than 4 pulses per revolution. We seem to get better resolution and better reliability going that way. In this case, because it is a lab and I'm using an RPM simulator, that is why I have 3 pulses per revolution selected there. I have some global things right here that I can do for the digital outputs. Remember, number 1 terminal board from last week's class, we have 8 digital outputs on it. So I can assign some global assignments here. We'll cover them one at a time. This first option is to enable the digital output 5 for integrated timer output. You can see that I have the default set as 30 minutes. So if the unit is running, this output will be turned on. Once it shuts down, it'll remain on until a timer of 30 minutes expires, and then that digital output will turn off. And we can use this for a number of things. I happen to use it in this lab piece to simulate I'm shutting off power to an external device, such as an engine system or an aftermarket air-fuel ratio control system. The next one is to enable digital output 6 for an alarm. This could be used to trip a relay or a light on the face of the panel to indicate that there is an alarm, or both. Enable digital output 7 for service meter expiration. The service meter expiration's always been part of the DE-3000, but I hadn't seen up until recent years a lot of people using it, but now I'm seeing more and more people use this service meter expiration. So you can put, and we'll get to that later in the software, but just real quick, you can put indicators in there like every 9,000 hours I'm supposed to check and clean the air filters, or every 20,000 hours I'm supposed to go in maybe adjust the valves on the engine, et cetera, et cetera. And when the service hour meter, something expires in one of these hour meters, we can use this output to, again, trigger a relay or an LED that's located on the face of the panel. And the last one is to enable digital output 8 for a fault condition. This is very, very commonly used on just about all panels. And what this does is when the system faults, it will turn on digital output 8. So we'll return back to the global configuration main page, and we're going to look at a few things over here on the side, on the far right-hand side with the startup configuration. So there's 3 of them right now: disable, OEM Engine Control, and Auto Start. OEM Engine Control is a newer feature. It was introduced in mid-2014 as part of the version 2X or the enhanced DE-3000 release. We're going to cover them one at a time, so I'll start with disable. So disable is commonly used if somebody has an older annunciator system, such as a DD40 or a DD20, and they simply want to upgrade to a DE-3000, but they don't really want to change any controls out on the unit. They can simply push reset on their main keypad, on the keypad of the DE-3000, or trigger a remote reset, and they'll simply turn on outputs 1 and 2 instantly. But what we do have is in this middle section is we have an option to when do we turn off these 2 outputs. So let's use an example. Let's say we're using output 1 to control the fuel valve, and let's say we're using output 2 to control the ignition or the G lead. So on a fault, I would want the ignition to shut off after the fuel. And that's exactly what this is indicating. So it's output delay time in seconds, and there's one little word missing from this statement here in the center of your screen. It should really read output delay time off in seconds. So this kind of confuses a few people. Once you know this, it's imprinted in your brain and you'll never forget it, right? So if I wanted to swap this around and use output 2 for my fuel valve, I could simply change that to 0. And then if I wanted to use output 1 for my ignition, I could maybe change that to 3. So on a fault event, the fuel valve will shut off first and the ignition will shut off 3 seconds later. And that allows any unspent fuel to be burned in the system. Any questions on disable? Okay. So we'll move into auto. Now, auto was the system that was widely used at the beginning, well, with all the legacy DE product line from 2000 all the way up to 3000 prior to 2014. And in some cases, if we were dealing with an OEM engine, we had to kind of fudge this and lie to it a little bit. Right here in the top is a new feature for multiple start attempts. So if we put the system into a remote reset configuration to follow this startup sequencing, and it failed to start after a certain period of time, we could tell it to restart up to 4 tries before it finally shuts down and will not start up again. Now, this is a nice feature, and we had a lot of people asking for it, but I do not recommend just simply going out ever to a site and turning this feature on if it's not designed for it, because there's a couple of things when something is going to try to start once, it fails to start, but then it's going to, a few seconds later, it's going to try to automatically start rotating and cranking again. And generally what we'll do in those applications is we'll fit the panels and or the unit with audible and visual warning. So that'd be a very loud siren and probably usually a strobe light. So we wouldn't ever want to activate this if the unit's not designed for it. So startup sequencing is right here. Now remember the DE-3000 power supply board has 4 primary output modules, and they're numbered 1 through 4. So when we talk about preloop time, preloop is always linked to output module 4. So it counts down backwards. So in the startup sequencing, if we wanted a preloop, here's where we would tell it what our preloop time is. So let's use an older, like a 6 1/4 bore cat. So like a 379 Caterpillar engine. Maybe it has a CPU 95 ignition system on it. We'll tell it, well, we want to prelube the compressor and engine, or maybe just the engine, for a total of 60 seconds. And then we want to disconnect the prelube when we sense a certain RPM, and maybe we say something as low as 100 RPMs. And then we do a delay before cranking. So watch out for this terminology here. Preloop time is the ultimate time this system will preloop. Delay before cranking is how long will it preloop before we send a crank signal. So let's say 30 seconds. So we're going to preloop for half of the 60 seconds, 30 seconds, before we engage the starter. Now the starter is linked to output module 3. So now it's turned on in this auto sequence, but we're going to tell it how long do we want to stay engaged. I'll say 15 seconds for this exercise. So now we're going to crank up to 15 seconds. Once we start cranking, we're going to say crank to ignition delay. So how long do we want to crank and purge any unspent fuel out of the system before we turn on our ignition? I'll use 2 seconds. Once we've turned on our ignition to fuel delay, how long do we want to have it cranking with the ignition on before we turn on our fuel. I'll add another 2 seconds. So now we started cranking. We're going to crank up to 15 seconds and then abort. We're going to crank for a total of 2 seconds before we turn on our ignition. We're going to be cranking with our ignition on for a total of 2 seconds. So now a total of 4 seconds before we turn our fuel on. And at that time, we're hoping we start up. The last question in this lineup is post-loop time. So if we shut down, how long do we want to reinstitute the same preloop pump, output number 4, for a post-loop event? I'll say 60 seconds for this exercise. And again, at fault, when we do fault on the system, by the time we've started up, we've told it a few things here about disconnecting the preloop and the starter. Up here on this top line, crank disconnect, we've told it disconnect the starter, aka turn off output module 3 on the power supply board at 350 RPM. We've told it at 100 RPM to turn off output module 2 for the preloop. And what we hadn't told it over here is when to turn off the ignition and fuel. We're going to always use, in this scenario, output module 2 for ignition. So that gives us back up to here. So at fault, when would we want to shut off ignition? At least 2 to 3 seconds after we've shut off the fuel. Fuel is the last output to turn on in the startup sequence, so that means it's output 1. And generally, we want to always shut fuel off first on an engine such as this. Any questions? Okay. So, auto start, again, was originally created for an old school engine that we wanted to give some automation to. One last thing that I'll add to here, the only way to trigger this system into this auto start sequence is by triggering the remote reset, momentarily either opening or momentarily grounding the R terminal on the primary terminal board. So what happens if you push reset at this point on the face of the DE-3000? The answer is the startup sequence will not occur. Preloop output module 4 will not energize. The starter output module 3 will also not energize. But what will happen is outputs 1 and 2 will turn on instantly. And a lot of people ask, well, why do you do this? Well, one, that's exactly what happens when you're using the disable feature. But for the auto start feature, I think that's kind of critical. Because if I'm out at 1 o'clock in the morning trying to start a unit and it fails to start a few times and doesn't even try to start, I now have the ability to go and push the reset button on the face or the keypad of the DE-3000 to turn these two outputs on instantly, and gives me an opportunity to go and investigate. Is my fuel doing what it's supposed to do? Is my ignition doing what it's supposed to do? Because we can use these outputs to, yes, ground a G lead for the ignition, or we can also use these outputs to power an ignition system, such as a CPU95, a CD200 ignition system, etc., etc. Any questions on that? Okay. So the newest feature is the Oem Engine Control. And this was developed in lieu of a lot of the engines that we have that have their own computers on them these days. So a CAT Atom system, a Waukesha ESM system. Those systems generally look for 1 to 2 signals to start, and when they start, they take over the cranking process. They control their own preloop and postloop time for the engine, and they also control their own crank cycle time, which can be good and bad. So we have the same feature up here about the number of start attempts, and the same thing applies here, obviously. Delay between start attempts, multiple start crank / multi-start disconnect. So again, I have 350 here. And then we have a feature that says time to reach 350 RPM. In this case, I have 160 seconds. So if I don't reach 350 RPM by the time 160 seconds expires, I will fault down out on what we call overcrank. Familiar term, I think, in our industry. Right below it, we did something a little bit different to help alleviate some confusion. We added some numbers in parentheses by the numbers that we select to indicate what output module we're dealing with. And the same still applies. Preloop is always going to be output module 4, but 2 and 1 and 3 do something a little bit different on this sequencing. Preloop time. So if you'll notice, I also have 160 seconds here. The problem is, if I don't hit 350 RPM by the time 160 RPM, or I'm sorry, by the time 160 seconds expires, I could fault out on a preloop fail. Well, I have two timers the exact same number, so I kind of have a 50-50 shot at times of which one I'm going to fault out on. So generally what I like to do is give this one about 5 seconds longer than the RPM, because what I'd rather know on most designs is that I went down on overcrank. I failed to reach my RPM by this time. I have other things that I can do elsewhere in panel designs for preloop fail warnings. Again, just like the auto start attempt, I have a preloop disconnect RPM that I can enter in. And a lot of times I'll use this number as a low value because I know that that number usually I'm cranking faster than 150, and maybe I want to drop out the preloop pump while I'm cranking to free up extra volume for the starter on an air system. Post loop time. Well, on this one, if I'm prelooping because it's an OEM engine, chances are I'm only prelooping the compressor. The engine controls on these smart systems its own engine preloop. In most cases, nobody needs to or wants to post loop a compressor frame. So generally, this one would stay at 0 seconds. And there's always extreme cases in different designs, but we give you options. The purpose of post looping is generally to cool off turbos on an engine system. Start signal delay before on. So generally, this again becomes my true preloop time. So in this case, I have 60 seconds. So what I'm doing is I'm going to preloop this compressor. So far, based on what I'm saying in my logic, I'm going to preloop this compressor for 60 seconds before I send the start signal to the engine. Now, start signal hold after stop. Some OEM systems are different from the others. Some OEM systems, this needs to be 0, such as La Waukesha. Caterpillar, we want to have at least a 1 second delay on their OEM systems. Start signal on time. Again, on Caterpillar engines, this would remain on. Once we initiate the start signal, we keep it on the whole time during the run process. But if it was a Waukesha, say with an ESM system, we would pulse it for 2 seconds and then turn it off. All the Waukesha wants is just a pulse signal. So we have those options. Auxiliary delay before on and auxiliary hold after stop. We can do a lot of neat things with this output module 3 because again, originally output module 3 was used for cranking. But because this is an OEM engine, and the OEM engine is now going to control this system, we can use this output for several different things. One of the things that I currently use it for heavily is for what we call skid safety valves, or I don't really like the slang term, but a lot of the companies that use these refer to them as slam valves for whatever reason. But they have an additional fuel valve and an additional start gas valve on the side of the skid that when they don't need these systems, they turn them off. And we can do quite a neat strategy with this. And then the last one is output module 1, and we refer to this as driven equipment ready, delay before on, and driven equipment ready, hold after stop. Now, this will work the same way for whether we're dealing with a Waukesha or a Caterpillar engine or any other OEM system, but we do not let you change this. So we have 0 seconds on, 0 seconds off. This is the key critical most factor of how we're going to make sure this unit shuts down. Any questions so far?
Yes.
I tell you what, you've got some really bad feedback. So I heard you talking, but I did not understand that question. It sounds like you might have a phone connection on and a PC microphone on at the same time.
You go ahead and repeat the question, please.
Yes. My question was, are these changes to making made with the DFI?
Mr. Price, we're having a very, very hard time hearing you, sir.
Okay.
Yeah, I apologize. I can't quite make that out. Maybe an email question.
Or just use the chat button at the top of the screen here. If you type us the question here, I'll make sure that John gets that and we get an answer.
Okay, so I think that wraps up. We'll do our best to get that question addressed. And what we'll do for right now is we'll advance to the next section. So what I'm going to do is I'm going to click Save Global Data. And it's going to advance me into the channel section. And we'll run through this, but we'll kind of run through it a little bit quick. In this case, right now, we can see that channel 1 is my suction, what I'm calling suction pressure. I know it's pressure based on the PSIG in units right here over on the right-hand side. Now, for those of you who've been using the DE products for a long time but might be new to the enhanced DE-3000, this is a key critical change that's occurred. Used to be, and I'll tell you what I'll do, I'll skip ahead for just a minute and save channel data. Used to be that the DE-3000 on the legacy system received all of its labels from this label section. And if we saved the labels from this label section, this is also where the DE-3000 selected these channels that are populated in these areas to be the channels that you did the data logging on. You're limited to a total of 15 channels, 12 here on this page, and if I back up, 3 on this page for data logging. But the old legacy DE-3000 also used these 2 pages to populate the analog screens, analog meaning any channel that changes values, such as temperatures, pressures, etc., etc. On the new DE-3000, we do not use these pages to populate the labels on the DE-3000 screen. Instead, what we do is we use these labels from the channel section. The one bad thing, though, about this that's a little confusing, this section will let you enter in up to almost 20 characters right here. It does have a limit, but it's closer to 20 characters. What will happen, though, when this data that's populated in this section is programmed into the DE-3000, the DE-3000 is going to only cut you off after the first 9 characters, and that includes spaces. So it's real important with the new systems to the new DE-3000 system to come up with abbreviations that are 9 characters, including spaces, or less. So one of the things that we noticed we used to do on the legacy systems is we would say suction pressure. Well, when you're looking at the data, if you see the word suction and you see the value and then you see PSIG after it, you kind of know that it's suction pressure. So that was one of our solutions. But you'll see as I go through this, you may see some other abbreviations. And somewhere out there in cyber world, I do actually have some recommended abbreviation sheets. I think our engineering department and our panel division has those for sure. I don't know if we follow them every day, but that's my little disclaimer for the day about this section. The software will let you put up quite a few characters, but when you program a system, the DE-3000 display screen will only show the first 9 characters. So strongly recommend you keep your names less than 9 characters or less. So this channel is set up as a 4 to 20, and because this is my lab piece, I was doing some experiment with it. I want to change it back to a 0 to 5, so I figured that would be a great example for today. So I'm simply going to select analog input 0 to 5 volts / TC. So TC also stands for thermocouple. So now this channel could be either one, and I'm going to come back over here to the sensor selection, and of course we're starting at other, so we see the very bottom. Here's where I would select J-type or K-type thermocouple. But in this case, I'm going to program it back as a 0 to 100 PSIG pressure transducer. And I'm going to set my high kill at 50 pounds. And I'm going to keep my high kill as a class A. And I'm going to leave my low kill at 0 PSI and keep it as a class C. Now notice when it's a C, the time in minutes is grayed out right here, and it says 10 minutes. So that links back to the global timer for the class C timers on the first section that we covered. Also notice right here we have a cooldown channel and that we have a box checked for it. If I change the low to a class A momentarily, notice that cooldown is now grayed out and the checkbox has disappeared. So if both channels are both high and low or class A's, cooldown is not available. If it's a B or a C, cooldown is available. And then we can select it. So now this channel is assigned to be part of the cooldown channel assignment. So somebody might be asking themselves, well, what does the cooldown do? The cooldown is a way to where if we want to shut the unit down for planned maintenance, but we want to unload it first, we can have a group of channels that are disabled when we place the unit into cooldown. So from a running screen, we would push F2 and then enter to enter the cooldown, and a timer will start. In this case, from what we saw on the previous screen, 3 minutes. Once that timer expires, the unit will shut down, but in that time, channels that are selected as the cooldown set will become disabled, and that would allow us, in this case, to open up a blowdown, close the suction valve, and remove all the gas pressure from the system without getting a forced or fault shutdown. Channel 2 is not used on this one. I'm simply selecting next channel to go through the channel listing. Channel 3 is discharge 1. PSIG 0 to 1000. It's part of the cooldown set. Channel 4 is discharge 2, and it's part of the cooldown set. Channel 3, discharge 3, part of the cooldown set. And then we get to channel 6, compressor oil pressure. Notice it is a class B for the low shutdown set point, and cooldown is not selected. So we wouldn't want to ever, under any circumstances, disable a low oil pressure shutdown. That could be key critical as far as doing detrimental damage to a unit, right? Now, this is a key one right here. And for those of you who are becoming familiar with the DE-4000, it's also an issue that we've resolved. But time in seconds. So obviously we need a B timer for low compressor oil pressure. We have our default safety kill set at 45 PSI, but we have a time in seconds, 130 seconds, which seems like a little long time, but let's talk about this real quick. So what I'm going to do is I'm going to deviate and I'm going to go backwards to the global configuration screen so we can explain this. In the OEM start sequencing, that B timer starts counting the second I place it into an auto start configuration. Now again, same as the auto start, the only way I can get this OEM sequence to take effect is by triggering the remote reset terminals on the primary terminal board. For safety, one of the things, and I didn't cover this earlier, I apologize. For safety, one of the things that we did on this OEM start configuration, if somebody, remember, in the auto start, if we simply reach up and push the reset button on the front of the display, it automatically turns on outputs 1 and 2 on the auto start configuration. But on the OEM start configuration, it locks the system up for safety. It will go into timers active, but it will never read auto start across the screen of the display, and none of the output modules on the power supply will illuminate or be energized. The only way to get it out of that lockup state is to push manual stop and then return and use a remote switch that's usually located on the front of the panel to trigger or excite the remote reset terminal. Apologies, I'm jumping around a little bit. So I gave it a time to reach 350 RPM, or in my case, start up, 160 seconds. I gave it a prelude time of 165 seconds, but I gave it a start signal delay before on 60 seconds. At that point, I'm going to send a start command to the engine to start. But here's some other things that are going on in the background. "60 seconds, so I can add this 60 seconds to channel 6 for the B timer. But then once I send the start signal to that engine, I happen to know on most of these, this is modeled after a 3500 engine, Atom 3 system, so it's a smart engine. I know that that engine is going to prelude by default for 60 seconds. So now, if you couple the prelude time that I have for the compressor programmed in on the global configuration page, and you know that the engine's going to prelude for 60 seconds before it ever starts rotation from the starter. Actually, this 130 seconds is more like 10 seconds, and so I'm safe. The danger is if somebody goes back in on the engine system and programs in a shorter prelude time, they have to know to come and make an adjustment here. So this is key critical, and this is why I spend so much time talking to people about this. Another thing that we might notice on this screen that's different from the screens that we've seen so far is this number 4 box is checked. Well, remember, we have 8 digital outputs on the primary terminal board. 8 is utilized as the fault status or DE-3000 run status. So it's configured and already used on the global configuration page, so it's grayed out on all of these channels and we can't use it. Same thing, 5 has already been used on the global page for that timer or battery saver feature I was telling you about, so it's also grayed out. But that still leaves us 1 through 4 and 6 and 7 to use for many, many different things. In this case, what we're telling it is we want to turn on digital output 4 when the compressor oil pressure is equal to or greater than 10 psi. Why are we doing this? More than likely, what we're doing in the panel design is for a pre-loop pressure permissive. Sorry, was that a question? Okay.
John, I think it was just someone that seems to be having connection issues. They just rejoined.
Gotcha. Okay. So we're going to go through the rest of the channels kind of, and as we do this, we'll cover all the different things that we can do in the channel section. Channel 7 is what I call a preloop fail. We can see that it's a normally closed digital input type. It has a B-class timer of 60 seconds. Now, remember what we just covered on compressor oil pressure with the B-class timer and the startup sequencing. We kind of reviewed it again. So what we're seeing is, hey, wait a minute. In this case, and I'll kind of cheat a little bit here, we're turning on digital output 4 when the oil pressure is equal to or greater than 10 psi on compressor oil pressure channel. I'm using that digital output to energize a relay, and I'm closing a set of contacts for channel 7. So channel 7's monitoring this digital output. If this digital output energizes my relay, I know when the contact closes here that I'm okay. And being that I'm pre-looping for 60 seconds on that compressor before I go to the next step to send a start command to my engine, but I'm not disconnecting that compressor oil pressure or pre-loop circuit until I hit 150 RPM. Even while the engine's pre-looping, the compressor will continue to pre-loop until I hit 150 RPM. I know it gets a little confusing. So with a 60-second timer here, if I don't meet that pressure permissive, I will go into a fault about the same time I'm starting to try to send a signal over to the engine to start its startup sequencing. And so I told you earlier on the global configuration page, I had a way to not really worry about that preloop fault. Remember the preloop fail event? I said, put this at a greater number than the time to reach 350 RPM, because we don't want to see a preloop fault here. We want to see a overcrank issue here. But if we jump back over to page 7, we can see we had a different way to trigger a preloop fault. Next channel is channel 8. It's also a normally closed digital input. We can see that it's scrubber, number 1, LSHH, so a high liquid level. And if we count, we're probably going to see that there are more than 9 characters here. But this is not an analog channel. Analog channels are not the same. I'm sorry, this is a digital channel, and digital channels are not the same as what I was telling you earlier about having 9 characters or less here by the analog channel. So you can put as many characters here as a software allow. We can see it's a class A. We also can see that we can turn on digital outputs with a discrete channel. Now, this is the most important thing on this whole screen, fault condition. I had a gentleman one time call me up and he said, I'm not shutting down on any of my channels. And after spending a little time over the phone with him and reviewing his program, we discovered that he went in and he misinterpreted what this meant. He was novice to the system and he unchecked all of these. So if you want the unit system to fault and shut down if this channel is triggered, you definitely want to make sure that fault condition is checked on a discrete channel. There are some cases, and I've worked on many of these cases, where somebody wanted to monitor a discrete channel, so a normally open or normally closed switch, and they didn't want to create a fault, but instead they wanted to turn on a digital output, and that's why this is there for flexibility. I'm just scrolling through the channels. Okay, so we're going to get to a temperature channel. And again, we can see that it was selected as 0 to 5 volts or thermocouple, but it's programmed as a K-type thermocouple. Now the range on a K-type thermocouple for the DE-3000, if we hover over the low set point, we can see that it shows up as negative 76 for the minimum to 1472. And generally, what I will do on programs that I write, I want to disable the low kill. So I'll always set the low kill at negative 76. I'll keep it as a class A. And then again, my high kill in this case is 265. And it's also a class A. But it's not part of the, and because they're both class A's, it's not part of the cool down availability function. We can change the units from Fahrenheit to Celsius. And of course, it throws off our shutdown set points a little bit, and it just gives us a note to correct them if we need to. And I can keep it back as Fahrenheit. Lubrication channels. So this was a fun feature that we introduced in 2014 when we released the enhanced or version 2X DE-3000 as well. Channel 27 and 28 are the only two channels in the 3000 that can do this lube no flow option. And what the option is rather than using a ProFlow device or a simple Chemray no flow device, or the more common term, I think, is the DNFT, Digital No Flow Timer. We can use a simple proximity switch, or we can use the proximity switch feature only from those modern day DNFTs. So rather than them triggering the fault for us, we now can set up a time sequence to where we monitor the time in seconds between a full cycle of the lube system through that proximity switch. So it's a little bit of a hybrid channel, if you will. The channel, like we covered last week when we covered the hardware, wires in exactly like a discrete channel, or a normally open or a normally closed channel. The dip switches are configured as normally open, normally closed. We simply wire the channel through the proximity switch. The proximity switch will open and close. And on a full cycle, the channel now will count, and the rest of the changes take place in the software. We configure the software, and this is why I call it a hybrid. We configure the software as an analog channel, 0 to 5 volts, and we simply do one thing. We come down, once we've selected 0 to 5 volts, this lube no flow option goes from a gray out, where we can't access it, to a dark color, and we can check this box. And as soon as we check this box, all of this populates for us. It selects it as other. It scales it from 0 to 1,000 seconds. It grays out the low set point to where we cannot edit it because it's irrelevant, and it only looks at what we call the high or the run pulse time. And we can see here the kill is set to 70 seconds. We also have a Class B timer for startup purposes, and we have it set to 240 seconds. This has become a great feature because now if somebody's trying to adjust lube rates, they simply push the F1 button on the DE-3000 display and go to view what their time and cycle time in seconds displays. And then from there, that they need to adjust their lubricator pumps for their 4-speed lube system, they can do so. So you can see the same thing for channel 28. So channel 30 is the last channel on this particular system that is truly an input channel as far as channels 1 through 30. If I keep advancing to the next channel, we'll come to SO1. So that's speed 1 input. It's grayed out. We can't change the name. And here's where we could select our underspeed settings and our overspeed. Now this underspeed setting is going to work automatically about like a Class C timer. We can also notice if we look through this that we might see some different things going on. And in this case, we do. Again, this is a lab piece, so all kinds of strange stuff happens. I couldn't tell you exactly why this input is selected, but I'm going to loop around the channel section and come back, and we're going to do some experiments with channel 2 to show you a few more demonstrations. Channel A01, we can select a percent low point and a percent high point from 0 to 100. And we can do other things if we need to. I'll key in on that more once we get into the control section. But let's play with channel 2 a little bit. So let's just go through the different channel types. We have a normally open or a normally closed. Now, last week when we covered the hardware, we should have talked about the 2 different ways to wire up in-device switches, normally open or normally closed. And it's just either we have a jumper wire installed between the 2 terminals for that channel number or we don't. That's that simple. Changing the system from normally open to normally closed here in the software really does not do anything. But there is a section in here where we can print this program or get about a 4 to 5 page report from this program that will tell us this information. And so sometimes that becomes critical as far as maybe a supervisor in a packaging facility might print a report, and then that tech can go out on the shop floor and he or she knows, hey, I'm supposed to wire these channels up normally closed. I'm supposed to wire these channels up normally open. This day and time, it's probably not so much the case, but that's one option that it can be used for. But it absolutely changes nothing in the software when you select normally open or normally closed. They're going to work both the same way mechanically. We've covered 0 to 5 volts, but I'll spend just a little bit more time on it. Again, if I'm doing pressure, these are all the pressure sensors that we have available that are 0 to 5 volt. 1 to 50, 0 to 100, I'm sorry, 0 to 50, 0 to 100, 300, 500, 1,000, 2,000, up to 5,000. We also have degree type 1 and degree type 2 temperature transmitters that are 3-wire, work on a 0 to 5 volt premise. Degree 1 is good to up to 350 degrees. Degree 2 is good up to 450 degrees. I have a lot of customers that are going to these for all their water jacket.
Come on, people, stop being fucking dick.
I'm sorry, can somebody mute their microphone, please?
We're all set, John. Thank you.
Yes. So I have a lot of customers that are defaulting to these degree type 1 and degree type 2. So I'll show you one. As soon as I click degree type 2, it does come up by Fahrenheit automatically. And it gives me my range. I can select that kill setting anywhere between negative 143 degrees up to 675. Do not really agree with that's not necessarily what we say is the ideal range of this gauge, but that's what the software is letting us do. But we do specify this gauge or this sensor as good up to 450 degrees Fahrenheit. So that's one thing that we can do. Another thing that we can do, being that we've selected a 0 to 5 volt or thermocouple, is we can jump down and simply select a thermocouple. I did a K already, so I'll do a J. And again, if we hover over a minute, we can see the full range that the DE-3000 has the capabilities to see from a J-type thermocouple, negative 76 degrees up to 1382 degrees Fahrenheit. Pardon the pause. So the last type sensor I want to show you is a 4 to 20 milliamp. And we covered how to wire up a 4 to 20 milliamp, but there's so many different sensors on the market. We can do a lot of really neat things. So let's just focus in on a pressure transducer real quick. Let's call it field pressure. This is a very common one. Sometimes a lot of people want not to measure the suction pressure right at the skid, but they want to measure what the field pressure is. Maybe there's some suction control valves or block valves between this measurement point and the actual scrubber on the first stage suction of the compressor package. Well, one thing to know off the bat is when you select a new pressure range or setting up a channel, PSIA and absolute pressure will come up as your default. So just be sure that you change that before you're done here. The first thing you want to do after you've set up this top part is you want to select what your pressure range is, but be cautious here. When you're doing with 4 to 20, never select pressure, even though your pressure transducer may be a 0 to 2000 from this drop-down list. This drop-down list is reserved for the Altronic standard 0 to 5 volt pressure transducers, not 4 to 20s. If you have a 0 to 2000 pound 4 to 20 milliamp pressure transducer and you select this option, the scaling will be off. So what you want to do on a 4 to 20 is you want to always select other. And it's telling me my values are invalid. And that's kind of a pesky little message, because usually you say okay twice, it'll change the values over here automatically for you. But now that you've selected the sensor type as a other, you scale it manually. So we'll tell it 4 milliamps is what it's wanting to know. What does 4 milliamps equal? So I said that we would use a 0 to 2000 as our model here a minute ago. So 4 milliamps is going to equal 0 PSI. So we're perfect here. Likewise, on the 20 milliamp side, 20 milliamps is going to equal 2000. So we will scale it. So you always want to scale a 4 to 20 manually, in this method. And now it does say PSIG. I don't remember changing it. Maybe it changed it automatically. Oh, no, take that back. When you select other, it generally takes the last default that you were dealing with in the program for any program file when you're setting up a new channel and selects that unit of measurement here for you automatically. That's what happened here. It's no longer is it selected from a drop down. So you can scale this to anything you want to when it's scaled as other. Another good example of what we can do with a 4 to 20, and I've done this for several people. Let's say somebody has a H2S site, and so they want to add in an H2S monitor. Oops. And I do like to use cap locks on this. It just looks better on the screen, I think. So we have H2S, we have other, and now we have to go to the manufacturer that's manufactured the sensor, or the person who's manufacturing the sensors. They're going to have to tell us how this 4 to 20 milliamp H2S sensor is scaled. The most common answer I get when I'm setting these up for people is 0 to 40. And the units of measurement is parts per million. And in some cases, the customer will say, well, we don't want to shut it down, so we'll simply set the low kill at 0 and the high kill at 400. But they'll say what we want to do is at 10 parts per million, so we'll use a high control set point. They want to, and we'll use a spare output. They'll say, we just want to sound an audible alarm and a strobe light in the plant so our workers know to take action. And so that's a great example of how we would set up a 4 milliamp H2S monitoring system in the DE-3000. Another good example of what we can do with people, or with 4 to 20, is some people want a higher end vibration sensor. We can do a compressor vibration sensor. 4 to 20 scaled, 0. Now, we'll scale it a little bit higher resolution, so we might put 0.000 for the low. And we may scale the high side as 2.000. And now the unit of measurement would become inches per second as a common engineering unit of measurement. Super simple, right? Let's use something else. One thing in these channel section that we hadn't talked about is we hadn't talked about all this verbiage here in these low set points and high set point areas. And I'd like to spend just a little bit of time explaining this to you. So the DE-3000 with a one board system has two analog outputs, analog output 1 and analog output 2. Sometimes we can refer to an analog output as a loop. It's a current loop. And so the terminology is pretty straightforward here. This also affects the solenoid pulse control if we want it to. But let's take a look at this. Output decrease inhibit on loop 1. Output increase inhibit on loop 1. So what we're saying, inhibit. We can't increase it, we can't decrease it. Force output decrease on loop 1. Force output increase on loop 1. So, and these two force, what we can do is we can force it to decrease or force it to increase based on a condition. So I selected channel 5 third stage discharge pressure for a reason here. Let's say I may have a loading or a horsepower issue. And let's say at 1000 PSI, I want to make sure that I cannot go higher in suction pressure. Maybe I'm going to shut down, maybe this is a gas injection system. So let's assume that loop 1 or analog output 1, I'm controlling a suction control valve. And so I could simply say at 1,000 pounds for a high set point, output increase inhibit on loop 1. Now what that's going to do is if my suction control valve is trying to open up to give more suction pressure, but I'm fixing to shut down on high discharge pressure somewhere up above 1,000 pounds, I can say when you hit 1,000 pounds, don't let the suction pressure come up any higher. Let it freeze in time. It can go down, but it can't come up. And we're talking about the position of a suction control valve or a suction control motor valve, if you will, if you like that terminology better. I have used just about every strategy on here for different applications, from screw compressors to recips to offshore units, et cetera, and we can do some really fun, neat things here with this setup. Any questions? Okay. So we can do the same thing with output or with loop 2, and we have high and low control set points. Now, one such place that you might see this really common on some of the panels that I design or have been involved with the design on would be SO1. And let's see, what would I do? What's very common on a low control set point? Well, if I look at a drawing for a moment, and this is just a generic DE-3000 flex panel, I can see a circuit where I'm using output module 3 on the power supply board to supply through an ESD switch, 24 volt power. So I can say on this one, closed at auto start, and we'll just stop right there. So when it goes into auto start, this closes and puts 24 volts on this circuit. Sorry for all these little pop-ups. I'll try to keep my mouse from allowing that to happen. I'm providing 24 volts to the circuit 114. Now, at that point, I'm providing power to the power side of CR7, which is a gas start valve relay, and I have to close this contact on that same relay in order to get voltage over here to the start gas valve. And so one of the things I'm doing here is I'm using digital output 1 linked to channel SO1 speed low control set point. So that has direct relevance back to this page in the software. So I can automatically go on and say, hey, you know what, I need to check that, number 1. And so now it says close when engine speed below start gas valve permissive. So what we are saying, if we look back at the software, if I'm below 500 RPM, close this or turn this output on. And what that's doing for us is that's allowing voltage here with a ground here, that's allowing this relay to energize, and this contact goes closed, and we have power now to energize a start gas valve. And this is, again, I mentioned earlier that there's a lot of people that use start gas safety valves on the edge of their skid. It doesn't actually control the start, but what they're trying to do is they're trying to turn the start gas valve off if they don't need it. So if they're up and running, they don't need start gas valve pressure. So what we're saying here is soon as the RPM becomes greater than that 500 value that we just saw from the software, this will de-energize and the contact will go open. We'll de-energize this relay and this contact will throw open, and we will de-energize our start gas valve and it can return to the closed state. So the reason I like to show you that is it utilizes two things. It utilizes, one, the low control set point, something that I hadn't shown you in the software yet. But it also utilizes some of the strategy that I said we could do with output module 3 on the OEM startup sequencing. A lot of people use start gas pressure to do two things: control a preloop cycle as well as supply for their starters. So the second note on here is it says open on fault 0 seconds. Open delay 60 seconds. Off delay option for post loop. So the verbiage is a little bit confusing, but if I reread it, closed at auto start, open on fault 0 seconds, period. This should really be a whole new line. And it should really say, for post loop option, open delay 60 seconds or 60-second off delay. So what we're saying is if we revert back to the software, if we want this valve to open back up on a fault and allow pressure to be available for a post loop event for a period of 60 seconds, we can jump completely back. I'm going to save the changes I made and then jump back. We could jump completely back and we can say right here, output 3, auxiliary hold after stop, 60 seconds. I hope that gave you a little bit of insight about how we can use the different digital outputs along with the output modules and the startup sequencing linked to how we design the drawing to do some fascinating control strategies with this system. So moving on, I'd like to get out of the channel section and go into the control section. So I'm simply going to save the channel data. And I'm going to move into the section called Program Control Values, control being the key word. Now, for time restraints today, I'm going to kind of skip over the solenoid pulse control. Again, this is reserved and used for rotary or screw type compressors. The two biggest things are analog output 1 and analog output 2. Again, these can be referred to PID loop 1 and 2, loop 1 and 2, or analog 1 and 2. So just understand there's lots of different terminology, and I think we're using at least 3 of them within the software and in our drawing designs. So let's talk about PID loop number 1 first. On the 3000, it's a little bit different, I'm finding out these days, from some of the other terminology that's out there on the market, but proportional, integral, and derivative still mean this exact same thing. If you ever want more information, I have a little information on my YouTube channel about proportional proportional, integral, and derivative. Also, if you go to YouTube and you just do a search for PID, there's a Australian gentleman, little gray-haired fella, that does a great demonstration explaining what the definition of proportional, integral, and derivative are. He's one of the better persons that I've ever seen explain it. I strongly recommend you watch it if you're interested in this. But there's a couple of cool, so proportional, integral, and derivative, how we tune the reaction time and the reaction speed and the reaction amount of this analog output. But let's assume right now what we're going to do is control a suction control valve. Let's assume that the suction control valve is a fail closed, meaning it takes 20 milliamps to fully open and 4 milliamps to fully close through possibly a PID. I'm sorry, possibly an I to P converter. So I to P stands for amperage to pressure converter. So it's just think of it as an electronic regulator. So the first thing is the PID channel needs to be assigned to a channel as its sensor. Well, it's defaulted and grayed out to channel 1. What do we have at channel 1? Suction pressure. So we're perfect here. But it has to be linked with a channel. So suction pressure is what we're going to be measuring and basing what we do with the outputs for analog output 1. We have a deadband selection. Now some people, when they get up into really high pressures, like to use deadbands. Me, in my case, if I'm down around 50 pounds as my control set point, or under 100 pounds, let's just say, generally you're going to see me, if I'm tuning one of these systems up, select 0 pounds as my deadband. I want the system always floating. So what is a deadband? If I put a set point in here, and let's say I want to control at 40 psi. So 40 psi is my control set point. I want to give it no more than 40 psi for my suction pressure. So if the pressure crosses above 40 psi, it's going to try to close. If it drops below 40 psi, the further it drops, the more that valve's going to open up, trying to maintain 40 psi. So if I select a 1 pound deadband in there, from 39 pounds to 41 pounds, there will be no movement and no adjustment made to this valve. So that could tend to get me into a problem where I'm having too much of a sweep or too much of a differential, and I could for sure overpressure. So again, usually in most situations, in most applications, if I'm tuning one of these in the field, if the target pressure is less than 100 pounds, I'm going to have 0 selected as a deadband. Direct and inverse. So let's say somebody throws a kink in your curve and they say, well, no, my valve is fail open, and if I put 20 milliamps into it, it'll be closed, and 4 milliamps to it, it'll be open. Here's where you would change that. You would simply change it from direct to inverse. Now, forced increment error and forced increment error. The defaults are 5%. I've been messing with the DE products since I think I've got my hands on the very first DE product in about 2000, 2001. I've never changed these, never had a reason to. So 5% works good for me. But let's talk about proportional, integral, and derivative just a moment. So the default for proportional, if you're opening up a new software program, is going to be 120. Integral is 20, derivative is 999. Proportional is the biggest key. So again, I'm going to let you kind of go out and look at some of the sources I mentioned earlier if you want to learn more about this. But I'm going to tell you at 120, this thing's going to be so slow and so unresponsive, you're going to have problems. 50 is my default go-to. If I'm using this for a suction control valve or a recycle valve, pneumatically controlled through an I2P regulator, I'm going to be using 50 as my go-to default. From that point, if I want to slow the response up of the valve or my action a little bit, I will raise this number slowly. If I need to speed it up further, I will lower this number. Integral is a way to fine-tune it. Generally, unless I'm having some issues, you'll see me never mess with it. Derivative, same thing. You'll see me leave it at 999. The biggest thing is proportional on our system. So let me move over to analog output 2, or the PID loop 2. We have 3 different functions, and I'm going to skip one because, to be honest with you, we've tried doing a lot of different things with it, and I've been unsuccessful in all my years, as well as many other people with this system. But we're going to talk about PID for just a moment. The PID works the same way if we select this option. We can select a couple of channels to look at on this one. We can select SO1 or channel 2. Those are the only channels we can select. So if we're going to be controlling, let's say we're going to control a suction control valve with PID loop 1 based on suction pressure, channel 1. And then with PID loop 2, we want to control a recycle valve, again based on suction pressure. With this, knowing this fact right here, all of a sudden I have to have suction pressure listed on channel 1 and channel 2 back under my channel section. Now, if I back up a little bit, I think I have that covered. Because I have channel 1 set up as suction pressure. Oops. Well, we did for a brief moment in time. I think at one point we had told and called this field pressure. And we had scaled it somewhere in the neighborhood of 0 to 2000. So this would be a perfectly acceptable arrangement if I wanted to use analog output 2 to look at the field pressure for a recycle valve application. And I'm okay at this point. So I simply select 2, and then I choose my values. So maybe I have a deadband again of 0, and maybe I set my recycle control set point at 15 pounds. That would make sense. So again, I had set this up with a 0 deadband, 40 pounds for our suction high control set point, and our recycle valve is now at 10 psi. So we're not going to let that field pressure line get below 10 psi. If it does, we're going to start opening up that recycle valve control. And again, you can see, because I just set this section up, there's that high default. I had set 120 earlier. This one defaulted at 110 instead of 120, but I can change it to my default go-to target. And this is just from years of messing with these things. 50 is my kind of go-to number when I'm setting one of these up. I'm going to save this real quick, and then I'm going to back up. And the reason I did that is because you noticed me having to go back and change this when I went back to the channel section. If you do need to back up in a program, don't want to lose anything that you've changed to go look at something else, always click save and then use previous screen to back up. So at this point, we'll show you the linear ramp control. And linear ramp control was introduced in 2014 as a new feature for the 3000. And a lot of people were using the DSG 1611 gauge if they wanted speed control because we could do 2 points rather than 1 point. If I'm trying to do speed control based on 1 point of set point, again with this PID loop tuning, my speed could kind of go anywhere. And with the linear ramp control, we get 2 targets. So let's keep going based on 40 pounds for our maximum suction pressure and 10 pounds thinking about for our recycle valve, even though we just in essence kind of took off our recycle valve by switching over to linear ramp. But let's follow this model. Let's say, hey, any pressure greater than 30 psi, oops, sorry, that's the wrong one. High variable, any pressure greater than 30 psi, I want to put out 20 milliamps and run full speed. Let's use a small horsepower package like a 3300 as our example, and let's say 1800 RPM is what our target's going to be. Now, we know that if we put out 20 milliamps, we will end up converting it for this particular engine that I just named to voltage with a resistor. So 20 milliamps will become 5 volts, but 5 volts will equal 1800 RPM. Likewise, let's say at 15 pounds, let's put out 4 milliamps, and that's going to be equal to 1000 RPMs. So now what we're going to do is we're going to create a nice, perfectly linear scale if we think about a graph. So if we think about a graph, let me turn on this feature here. If we think about a graph, 30 psi, 15 psi, one K RPM up to, what did we say, 18? That'll plot us a nice little flatline graph just like that as far as how our RPM will react. So we can tune it to where if the pressure is not wildly changing, we can see a nice gentle RPM sweep between these two pressures, between 1000 and 1800 RPM. Likewise, if we want to set a stop, for this, we can do that as well. So if we don't want to go quite all the way to 1000 RPMs for our low side, let's say we want to stay at 1400 RPMs, there'll be some math we have to work out, but we can change this system to now only work between 20 and 7 milliamps. So we have a little bit of flexibility here. Current at stop fault is irrelevant because if we're controlling speed to a running engine, great. But if we're shut down, obviously we're not controlling speed for it. So I don't even spend a whole lot of time here. Warm-up delay. We can do warm-up 2 different ways for this circuit to start working. We can put a timer in here, or we can link it to channel 26 low control set point permissive, currently set at 120 degrees. So some of you may be asking, well, wait, what's channel 26? So let's go take a look. I'm going to save, and then I'm going to back up. And I'm going to jump up, use this drop-down arrow because it's quicker, to channel 26, and we can see that channel 26 is compressor oil temperature. It's a 0 to 5 volt or thermocouple. It's configured as a thermocouple, and it's set to the low control set point. And so a lot of people are going to say, well, wait a minute, why is a low control set point? Well, think of the low control set point at this point for the purposes of what we were just looking at for the analog speed control as a second high control set point. And the reason being we do that is in some cases, somebody might say, let's use 80 degrees Fahrenheit down here on the low, high control set point, which is going to be just like what it says. So if the oil temperature is equal to or greater than 80, it's going to turn on this digital output 3. What might I be using that for? In some designs, and I think I have a good example here, RPM permissive. Digital output 3 linked to channel 26, high control set point, closed when compressor oil pressure is above RPM permissive. So I just made that permissive 80. I'm going to close this contact when I'm 80 and turn on this relay. With one set of contacts from this relay, I'm going to open and turn off a red RPM permissive not satisfied light off on the front of the panel. There's a second thing that I do. And I'll see if I can't find the engine I referenced a moment ago, which was a 3300B engine. I'm going to use the other set of contacts for that same relay that we just saw to control a ground into an engine input. Now what this does is, because this is a smart engine or an OEM engine control system with its own little computer, if this terminal in this case is the original cat idle rate of speed, must be just, and a cat does some different things, but if I change the ground status on this, in this case if I remove the ground from terminal 8, the ECM no longer sees a ground on this circuit, it will go to what we call rated speed. As long as I ground this circuit on this particular engine, the engine will hold at what we call an idle speed. So with knowing that, and knowing how we might have built the panel, I could say, well, at 80 degrees Fahrenheit, turn on digital output 3 so we can unground cat terminal 8 and allow it to go to rated speed. But then, at the same time, I could keep my low control set point, which is going to act as a high set point for what I'm showing you, at 120. To where it's going to prevent the auto control speed from being able to work correctly until we hit 120 degrees. Now, the reason we might do that for some people, and some people may request that, is they'll say, well, at 80 degrees Fahrenheit, I want to be able to speed it up manually at least to where I can put a light load on it. But I want to continue to sit and monitor it and not load it fully put it into all auto sequencing until I hit 120. At that point, I can walk away from it. So that's part of the strategy or flexibility. To be honest with you, most customers that use these features put them at the same temperature. Usually they use the lower value at 80 degrees and they walk away from the unit. But if you read some of the literature from the manufacturers, they'll tell you that they want the temperature much higher before somebody really truly loads the thing hard and walks away from it. So that concludes the program control value section, and we'll advance into the next section, which is labels. Now, the DE-3000 home screen, when reviewing it, has a lot of stuff going on it, but basically it shows us 3 different sections or 3 different values. Traditionally, the most common ones that we put up here are speed for RPM, suction pressure, and final discharge pressure. In this case, third stage. But if you wanted to change something here, these labels here link with the channel numbers internally, and you'll note, some of you may notice that these channels are grayed out. And if we want to change this, we select from a drop-down. Now remember, we set up a field pressure. Maybe that's what we want to monitor rather than suction pressure here. So I select field pressure, and right now it still says channel 1 over here, but as soon as I click into one of these other two boxes, it changes to channel 2 automatically for me, and I'm done. That quick, that easy. Change it back to suction pressure. So that's how you would modify what you see on your home screen. And again, these are 3 channels now that will be monitored by the onboard data logging. And if we save this label section, we'll advance to the next label section. Again, the only purpose this section serves nowadays is for the channels that we want to data log, and it works the same way. We simply select the channel that we want to data log, and as soon as we click into the next box, if we change it, and of course I didn't change it just now, the channel number assignment will also change automatically. If your character is 9 characters or greater from the channel setup section, this section here limits you to 7 characters max. So it'll simply kind of give you a little warning, like a slap on the wrist, should you select a channel like that that has greater than 7 characters, but then it'll just cut off the last couple of characters. So again, the shorter names that you can come up with these channel names, the better you are. So I'm saving labels, and we're narrowing the end of the program sections. I see I'm getting close to running out of time. So I'll key in on what I can and try to give at least the last 8 minutes for questions. This is your total run hour meter. You can see I'm up to about 3,291 hours. If I wanted to change this, this is where I could zero it out if I needed to for any reason. For right now, I'll keep it at a higher value just for demonstration purposes. Service meter. So here's where you can set up service meters. And we did this in a class that I taught a year or two ago, and we selected some fictitious hours because what we did, we wanted to really test and see how it worked. So at the end of one day, we set up 10 and 20 hours, and we let it run, and then we came in overnight and the next morning, and we could see what was going on. But it gave us some really neat messages up on the screen that indicated, hey, you need to go look at your service hours and see what you need to do. It has its advantage. I would have to say, if I was back in the side of the business today where I was taking care of equipment out in the field, that I would probably take advantage of this and use these features. But they're very flexible. Is, to my knowledge, well, on the hour meter, for sure, the only way you can edit it is with the software. The service hour meters, you may be able to do a little bit of editing through the keypad. I would be lying to you right now if I told you one way or the other. But again, on something like this, most of the time I default and use the software to make changes anyway. So once you get to the end of the program, you can save the file, which if you've made any changes, I always recommend you to do. And so I'll simply give it the same name, but I will call it a R1 for today's purposes, and I'll make sure I put my dot back in before my PG7, and I'll save it. And if we look at that file real quick, we can see that I saved 2 files. So there's my 2 R1 files. So now I'm ready to abandon my program, or I can go and program my unit, which I don't have time to show you that today. I've run out. But I will show you a print screen real quick, or I'm going to attempt to. And I'm going to try to print this in a PDF document. We'll see how it works. So there the document is, and I'll open it up for a moment. And this is a handy document if you're a commissioning tech or just trying to, cover your tracks when you've been doing a project out in the field. But it tells you the channel number, the user label, the channel class, the time in seconds, the device type. The second page tells you a little bit more detail what your low shutdown point is configured as, your high shutdown point, so on and so forth. Tells you a little bit about what's going on in the startup sequencing. Tells you information about your service hour meters and your hour meter. And there was something earlier, and the reason I wanted to show you this, when I started talking about normally open and normally closed. Here's a great example. Right here, we can see that channel 7 is, all these discrete channels are actually all configured as normally closed, but this is where the tech, if he or she saw one that said normally open, all of a sudden, if they're building the unit, wiring the unit, they know to wire this one a little bit different. So with that, I'm going to say that I'm finished talking, but I'm going to give the last 5 minutes or so for questions and answers. Does anybody have any questions they'd like to?
I have one question about the linear control.
The engine control?
The linear control in that one.
Sure.
Go ahead. If you cross the limits of the control, what happens? For example, if you cross the higher limit, what happened with the RPM?
Okay, that's a good question. So the software is not going to let you invert these. So like as an example, if I tried to change this value to 14, something less than 15, see what happens? It stops me from doing that. So when we say low variable and high variable, this one always has to be the lowest number. And if we're basing it on suction pressure, which we are, again, and that's one thing I left out when I was explaining this screen, this section looks at channel 1 by default, so suction pressure. But let's say somebody wanted to control their speed based on discharge pressure. Well, one, with the statement I just made about it being defaulted to look at channel 1, we would have to reconfigure our channels. We would have to move discharge pressure to channel 1. And maybe I'll put in a high variable of 1200. I'm going to attempt to put a high variable of 1200 in. Oh, you know what? It's not going to let me because my channel is not configured as such. So let's change that. Let's fix that problem. I'll change it to 0 to 2000 real quick. Now it's going to let me put in 1200 for my high pressure. And how about I go with 1000 for my low pressure? So again, the pressures always have to be the lower number here and the higher number. But I can do a flip-flop if I want to make this system work backwards. An example is I could say 20 milliamps and 4 milliamps. And then I could change my RPM assignment. And the RPM assignment here really doesn't have too much to do with it. But now I just reverse the action of this. I told it at 1,000 RPMs to put out 12 milliamps, which will equal 1,800 RPM for my model engine. And at 1,200 RPMs, put out 4 milliamps, which will equal 1,000. And I see this as a very, very common thing with people wanting to do when they're compressor is on a gas lift surface or downhole injection type compressor application. So that's how we would reverse one and make it work backwards. Did that answer your question?
Yes, a little bit, but the question is if you rise to, I don't know, the higher pressure, then if the pressure comes higher, you how do they go? It's easy if I show you with a picture, but you go in a ramp, you rise, and then you maintain the value in the maximum RPM. So because we have one problem that when the controller gets to the maximum value, it goes to the lower RPMs.
Okay. Well, I think I'll do the best I can. So I switched back over. I just undid everything that I did to make it work backwards, and I switched back over to a suction control setup. What I'm thinking you're asking is what happens if the suction pressure actually becomes greater than 30 psi?
Yes, exactly.
Well,
that's
okay. So in this case, we set a suction control valve up for 40 psi, and we're going to control the speed between 15 and 30 psi. So if the pressure becomes greater than 30 psi, nothing happens. We stop at 20. We continue to run 1800 RPM. And for the model that I selected, in this case, I think I used a 3300 engine. The limit on it is 1800 RPM anyway. So from 30 pounds to 40, where our suction control valve is, we'll run wide open. Then if the suction pressure drops below 30, between 30 and 15, it'll start slowly slowing down to 1400 RPM in this case.
Okay, good. And if we have this problem that when the pressure gets higher, the RPMs goes to the lower RPM the system can maintain. And
wow. Okay.
I don't know if it's maybe a mistake in the configuration or you see that problem in some case. I don't know.
It could be. It could be. What I'd like to do is see a screenshot of this screen in your program, and
okay, I can send you later.
Yes, absolutely. You can email me at any time.
Okay, thank you, sir.
Any other questions?
Anything else for Mr. Nance? John, as usual, well done. Many thanks. Any questions for John? Let's see, a lot of depth of knowledge there. Pretty comfortable with this product.
Real quick with the cooldown timer. So does that, whenever you hit cooldown, enter, whatever, does it apply just to B and C timers, or does it apply to all three, the A, B, and C?
It will only affect a channel that is a C or a B.
Okay.
And it'll only affect the channels that you've selected this selection on.
Yes, that's what I just didn't want a green hat out there going out there and hitting something or closing a valve and you just blew a cooler out.
Oh yeah, no doubt. Yeah, and we I mean, if somebody comes in and changes the high shutdowns to a class B, then you got problems. But that's why I spend quite a bit of time on this one. So yeah, just make sure your high pressures are always set as class A's and you're covered.
Yes, sir.
And then again, make sure your key critical channels, such as something like compressor oil pressure or engine oil pressure, are never selected. Even though it's a B timer, it won't be part of that cool down feature if you don't select it here.
Yes, sir.
Okay.